A very good morning to all of you and a warm welcome to the Indian Electrical and Electronic Manufacturers Association's annual convention on this very spectacular virtual platform. I am Isha Bhalla, your host at the DigiElect Bharat conference with an all-new theme of Atmanirbhar Bharat that all of us today connect with very, very well. We would like to thank each one of you for your kind presence and being a part of the conference for these 2 days, which we promise that will have many takeaways for all of you, be it the power packed, interesting discussions, be it our power packed panelists, our fireside chats, our expert sessions, our dignitaries joining us, and of course, post which we will also be welcoming you to be a part of our virtual expo. So there is a lot more happening right here. And what excites us the most is the fact that we have had over 5,000 registrations so far, and the number is only growing as we speak. What better can we hope for when we bring to you first of its kind virtual expo right here? And what excites us even more is the various deliberations that we'll be covering today in our panel discussions and expert sessions. We will be talking about smart electric highway, the next frontier for the Indian power and EV sector, which will be the first thing that we start with from 11 a.m. to 1 p.m. This will be followed by a lot of questions coming from all of you as the audience. So please don't shy away from sending those questions. We would love for this platform to be very, very interactive. So please do send in questions in the chat box and our team will pass them on to our moderator. We will then follow it up with yet another track discussion of EV components and charging solutions, various opportunities for manufacturing, services, and financing. We have a very, very special address for all of you today, our keynote address by Shri D.S. Mishra ji, Secretary, Ministry of Housing and Urban Affairs. Another special address that we at the team are looking forward to is by His Excellency Upendra Tripathi ji, Director General, International Solar Alliance. We have yet another interesting track for all of you with our panelists, greeting the grid, building a resilient and a futuristic transmission grid in India, which will take place from 4:30 to 6 p.m. So a lot of excitement coming for you right here. But the first thing on our agenda today is smart electric highways, the next frontier for the Indian power and EV sector, which will be moderated by a veteran himself from the industry, Mr. Mustafa Wajid, Managing Director and Chief Executive Officer, Meher Group. He'll be chairing the session. And as most of you who know him are well aware that he started his entrepreneurial career at a very young age of 16 when he designed and manufactured his first power capacitor in Bangalore. This was the business start from back then, which converted into Meher Capacitors. As Managing Director and CEO of Meher Group, he now guides the team in transformation via businesses across power engineering, e-mobility, and digital domains, in addition to taking care of Meher Care. Before I welcome and hand over to him to introduce to you, all of you, our power packed panelists, I would like to extend a very warm welcome and bid a very good morning to none other than Mr. Anil Sabu, President IMA, to personally extend a warm welcome to all of you. Sir?
Good morning to all. On behalf of IMA and our NSE Executive Council member, I welcome and we are our representations to the government. Thanks to our Honorable Minister, Prime Minister for coining the phrase Atmanirbhar Bharat that has impetus to the goal of self-reliant India. Friends, to make it happen, IMA planned DigiElect Bharat Expo cum conference. This is unprecedented time. There are 5 views which we are facing. This type of situation is unprecedented, unexpected, unprepared, uncertain, and universal. And we have to cope up with it by 5 P's, that is people, purpose, passion, positivity, and persistence. And added to this, we have to think of innovation and technology. It is here that we planned this conference. And as our conference heading tells everything, transforming business through technology. This conference features 5 power-packed sessions focusing on business opportunities for our industry in new technologies, such as e-highways, EV components, and charging infra, renewable integration with the grid, industrial efficiency, and convergence of technology. And today, we are happy to start with the first topic on e-highways. And Mr. Mustafa Wajid, I welcome you, Mustafa Wajid, to take over this from here and introduce our speakers. I also welcome our all other speakers. Thank you. Over to Mustafa.
Yeah, thank you, Sabuji, and thank you, Isha, for a very colorful introduction. I wish most of that was true. Anyway, so let's get into the session straight away. Smart electric highways, what are they? They are basically highways on which vehicles can move and get charged as they are moving. Now, this is a technology which has been around in a thought process for some time. EMA took the initiative in 2017-18 when we invited the team in Sweden, which had done this project or was starting to do this project for the first time in the world on a particular section of highway in Sweden. This was discussed and deliberated upon in Elecrama 2018 and also set in motion a lot of discussions thereafter. So we have been at it for some time, and thanks to the work from home from COVID, we are able to focus a little more on new ideas. And that's one of the reasons why we are back at it again, and this time with a lot more information and a lot more practical aspects to be able to ensure it happens in India. At one level, we need to also understand that transportation consumes a lot of energy. Depending on which country you are, it could be anywhere between 25 to 35% of the total energy consumption of that country. This is a matter which is, of course, flexible because there are developed countries, there are developing countries, and so on. But the reality is that transportation is a very important energy consumer. Coming to India, most of this transportation energy, or most of it in the world actually, is today done or met with by oil. There is very little energy that is provided by other sources. The consumption of petroleum obviously causes pollution and environmental issues. Those of my colleagues in India who are living in Delhi have been victims of all kinds of traffic management strategies to reduce that pollution. But the reality is that we have to find a sustainable solution for this. We have to find a way of electrifying transportation without getting into new dependencies. It's easy to say remove petroleum, but if we get dependent on lithium, I don't know which one is worse. At the same time, we need to have a sustainable model. From an environmental point of view, we should be able to produce renewable energy in the form of electricity and use it for transportation. This will be the ideal situation. Today's session on smart electric highways shows a way of doing that on highways. It is important to remember that in India, 55% or so of the diesel consumption for transportation is used on the national highways by trucks and buses. My friend and senior colleague Sudhir Garg Sahab is here on the panel. He will obviously give a lot more insight into that. I have learned a lot from him interacting with him on this topic for the last 2 years. Government policy evolution is a very important part of this whole program or this whole track. It is also equally important that the electrical industry and the automotive industry start synchronizing their activities and speak in one voice. So today on the panel, ladies and gentlemen, we have a situation where we have panelists with experience of deploying and monitoring pilot projects in electric highways. Broadly, I will mention their names, but give more detailed introductions later. We have Mr. Sudhir Garg, who is Joint Secretary, Government of India, who is overseeing this project of the smart electric highways and has a lot of ideas on around the subject, done a lot of work, and much of what we will discuss today in this panel he probably already knows. But it is very important for these inputs to get structured into a policy which he will be probably driving based off his position in the government. Along with him, we have, in order of sequence, Mr. Anupam Arora, who is General Manager at Siemens E-Mobility. We have Mr. Oren Yezer from Israel. He is the CEO of the company Electrion, which has been very much noticed for having done the wireless transfer of power on highways and on urban roads as well. We were supposed to have Mr. Jitesh Khanna from McKinsey. Unfortunately, he was diagnosed COVID positive yesterday. And in his place, we have Mr. Gaurav Ganguly, who is there from McKinsey, who will share the views that they have done a lot of work on. And last but not the least, I would like to make special mention of a very reputed and a very sort of well-recognized engineer from the automobile industry, who is Mr. Sundaresan, a good friend of mine. He is Vice President at Ashok Leyland, one of the largest producers of heavy vehicles in India, and a very old company which has been producing these kind of vehicles for many years or many decades. Mr. Sundaresan is in charge of electric vehicle mobility, both products and solutions at Ashok Leyland. None of this electric highway stuff can happen without the automobile industry actually joining hands and providing a sort of a leadership role in this effort, along with the government and the electrical industry. So we will all be anxious to hear the views from Mr. Sundaresan, which would represent broadly the views of the automobile industry when it comes to electric vehicles. So with this kind of a brief introduction, I wish all of you the best for this session. It's going to be a very exciting time. I'm sure there will be a lot of questions which cannot be answered today, because this is a new topic, and in any new topic, it's disruptive. There are always pros and cons. There are always advantages and disadvantages. But this is a very important beginning, because strategically, it is important for India. Why is it important for India? We must reduce petroleum consumption and substitute it with renewable energy and electrification of transportation. This will be the ideal solution for India. We will also clean up our environment. This is why this session is critical and important for future work. With this, I now request Mr. Anupam Arora to come forward and make his presentation on smart electric highways based off their experience of Siemens done in various countries in different parts of the world. Over to you, Anupam. And before you start, I would like to give a more detailed introduction of Anupam. And just a moment. Yeah, Mr. Anupam Arora is currently the head of rail electrification and electric mobility division of Siemens. He, as an engineering graduate from Delhi College of Engineering, like me, he has also lost enough hair, so I don't want to go into the decades of experience that he has. He's both a technology person as well as a business person, has held several important assignments on both fronts, both in India and internationally, and is probably having a collective experience across the railway sector, the metro rail sector, and now the electric highway sector. He's obviously very passionate about this topic. He's also having a deep understanding of things like power distribution and power electronics, which is important in this whole solution. With this brief introduction, I know, Anupam, it doesn't do justice to you, but over to you, because we have a time constraint.
Thank you, Mr. Mustafa. I hope I am audible to all the panelists and the audience. So, good morning, respected dignitaries, delegates, audience, and panelists. So my name is Anupam Arora and I am from Siemens. I lead the rail electrification business. And e-highway is one of the most important forthcoming topics for us because the technology of e-highway is straight away taken from the railway technology. And it's my honor to introduce and talk about this topic to you today. So while we talk about this concept, a lot of questions come up. Simply said, e-highway is a technology where, as Mr. Mustafa said, the long-haul transportation is run on electricity drawn from the power grid, and the whole aim is basically to reduce the greenhouse gas emissions and improve the energy efficiency in the transportation. Now, of course, a lot of questions come up. Why so much trust and importance to this topic? Why is there an urgency in converting the long haul transportation to e-highway? What exactly is this concept? What are the factors on which the different solutions depend upon? And what are the different options available with us? And what is the progress on the global pilot projects, especially with this technology? And what is the way forward for India? So these are the typical questions and topics which which I will address in my session. So on the screen, you see basically a snapshot of surface freight density 2010, which is basically showing the billion ton kilometers traveled on the freight transported. Now, increase in transportation of goods is an important indicator and key element of the economic progress. And over here also in the slide, we see that Europe very much at the center stage of the global freight transport network, and Germany especially over there. And India, mostly the long haul transportation is around the golden corridor. Now this is the picture of 2010 and how the picture looks like in 2050. What are the projections for 2000? Now, suddenly the scenario changes. Of course, the Europe continues to be very densely populated in freight transportation density, but then Asia takes the center stage over here. And especially India, if you see over here, it is no longer now confined to the golden quadrant. It is spread all across. And Asia, from being 50% in 2010, now becomes a key contributor of nearly two-thirds of the surface freight density. And all this very good for the key economic growth of the global economy. But then the question is at what cost and what climatic implication? So the next slide we see over here. If you see the chart on the left hand side and follow the purple color, now this is where the dimensions of the trucks are given over here. The vehicle population in terms of trucks is 9%. But if you see the distance covered by them is about 17%. But if you look at the greenhouse gas emissions, a whopping 39%. So this is the disproportionate dimension of a long haul traffic, and where we see that the greenhouse gas emissions becomes very critical to control them with respect to the long haul traffic. And since and this is still the statistics of 2015, but when we come to the statistics of projections of 2050, as per the International Transport Forum, it is estimated that the global emissions from road transport will actually grow from 3 gigatons of carbon dioxide in 2015 to 7 gigatons by 2050, all by heavy truck activity on the long haul transportation. Now, this is where it becomes very important to really address this fact and to decarbonize the long haul transportation. And with the kind of the emissions which are there from the trucks, the world cannot simply afford to wait for another 10 years to start this initiative. And that is how a lot of thrust is being put on the various technologies, options available, and e-highways one of. Now, people may ask that why not really batteries? Well, in recent years, of course, the decarbonization of approach of car and van industry has been around the battery. And there is a clear trend towards the battery electric vehicles now in India also, transitioning from the petrol and diesel power. Now it has given very good results and can virtually achieve the zero greenhouse gas emissions, ideally suited towards the light duty passenger vehicles and also the smaller goods vehicles. But when it comes to long haul traffic and heavy trucks, there are challenges. The scaling the battery technology to the large heavy good vehicles on a long distance traffic, it has severe challenges. Yeah. And the kind of energy and power which is needed for operation of such long haul heavy duty traffic, it means very high and really impractical sizes and weights of the battery. And that is why globally there is a need to really find an alternate solution. So decarbonization of road freight, especially the long haul transportation, is now urgent, and then the government globally and policymakers are looking for solutions. Now, what are the criteria for finding such a kind of a solution? So one is, of course, that it has to really address the core concern of greenhouse gas emissions. Secondly, going by the statistics and the urgent need, we can't really wait too much to develop a new technology. So ideal case would be that a technology which is already available from the available platforms and which is mature to be automatically inducted into the long haul freight traffic. And the third is, of course, that it has to be economic and a business case has to be there for all the stakeholders, which are, let's say, the government, the utility energy provider, the infrastructure provider, the vehicle owner, and the owner. So what are the various options over here? So over here we look at, that there are 2, 3 different options available. But of course, the importance, the various criterias, the readiness of the technology level, everything differs. Yeah. If you see over here, even by electrolysis and generating hydrogen, we can create fuel cell trucks. We can also create also synthetic fuels, which can really address the problem. But any process of electrolysis and the further distribution also deals with a certain losses on the way. And if you see over here the energy figures at the bottom, the efficiency which is achieved out of the synthetic fuel and the hydrogen is barely around 30 odd percentage. Whereas if we transition to a electric system, which basically only deals with the losses which are there in the distribution and a direct feed from the utility to the infrastructure and to the vehicles, it achieves an efficiency nearly about 70% plus. Also coupled with the fact that the energy can be also fed back during the braking times. So how does an electric highway really work? So there are 3 components of this complete technology. One is, of course, that we have a power supply distribution with the wayside substations, which are providing the power to the second component, which is the overhead contact wires. And there are 2 wires over there, positive and negative, with respect to the solution implemented in Europe so far, in Germany, where Siemens has been pioneering this concept. And there are, it's already working, we are already working on 3 corridors in Germany. So this is based upon right now the DC technology, 670 volt DC, which has been the base of the concept in Europe. And the third component is, of course, the hybrid drive itself, where the truck's hybrid drive enables the full electrical operation coupled with the fuels also, which is also important that that while we transition from fuel to electricity and electricity to fuel, such changeovers are expected because whenever we are overtaking and we come out of the wire system, it has to run on a hybrid fuel power. And there could be some regions of non-electrified parts of the road where we need to bridge towards the hybrid solutions, and also to cover the first and last mile of the journey. So this is basically how the technology works. And Siemens has really pioneered the research and development in this technology, from substations to the catenary and interface from the pantograph, from the concept towards the implementation. The two global implemented corridors in Sweden and US, which have been demonstration projects or pilot projects in those countries, have also been based on Siemens solutions. And right now, we are also implementing 3 different corridors in Germany. This is basically the 3 projects are identified by keywords which are basically coming out of German words. Basically, the first is Project ELISA, which is somewhere in Autobahn A5 near to the Frankfurt, which is a 5-kilometer corridor. And this has been successfully implemented and officially started on May 7, 2019. Second is the project FESH, which is currently under implementation in the state of Holstein between Rheinfeld and Lübeck, also a 5-kilometer corridor. And the third is we have recently won this, which is E-Way BW, which is Baden-Württemberg, which has 3 corridors of 3.2 kilometers, 0.7 kilometers, and 1.7 kilometers, all across Highway B462 in Germany. So these are the 3 projects which are being currently implemented by Siemens in Germany. And definitely the government is also putting a lot of thrust over there, coming out of the success of the first pilot project which we did around Berlin.
You have 5 minutes more.
Yeah, sure. Going by the success of this pilot project and the implementation in Germany, many European countries have also now tried to adopt this and have started their own pilot projects. Of course, Sweden started everything along with Germany, where Siemens has also put the pilot project. And Sweden now has a plan to start building 1,500-kilometer electric highways by 2022. UK also has now announced its pilot project. This is in southern Yorkshire area. And Germany, in any case, is committed to intensify the electrification program by 2030 already. Hungary also has announced, Austria also has announced, China is also trying to get deeper into the technology. USA was already there in California area when Siemens started it all around the world. And even in India, Gadkari also has announced that there are plans to electrify Indian highways with the catenary system. And already talks are going on for a pilot project around Delhi-Mumbai highway. With this, I would like to showcase a small video which really summarizes my topic and also the concept and the technology. Yeah.
Road freight transport predominantly depends on combustion engines running on fossil fuel. The resulting carbon dioxide, nitrogen oxide, and particulate matter emissions put at risk human health and the environment in general. Here, the e-highway system provides substantial relief and is also economical. Like a conventional truck, the hybrid vehicle has a combustion engine. But in contrast to conventional trucks, the e-highway vehicles also allow for purely electrical operation. To connect the system, a sensor checks whether the traffic lane is equipped with a contact line. The truck then automatically raises its pantograph, or the driver manually initiates the process. The pantograph actively positions itself to the overhead contact line, which is continuously supplied with electric energy by the substations. When connected, the pantograph transfers this energy directly to the electric motor. Simultaneously, it can charge the battery. Sensors and actuators ensure that the pantograph remains connected and that wear is minimized. During braking, electricity is generated as the flow of energy is reversed. This electricity can charge the battery on the e-highway truck, power other vehicles connected to the system, or be fed back into the network. The pantograph allows for flexible operation of the truck in all traffic situations.
So thank you very much, and I hope you like the introduction to the subject and the work which Siemens is doing globally and especially in Germany around this technology. Thank you very much.
Yeah, thank you for that, Anupam, and thank you for holding the time limit. I know that you were under a lot of pressure for that. Unfortunately, I'm not sure how many people could see the video. There was some setting issue, I think, but anyway, we'll make it available offline on the Digilec Bharat website of IMA for visibility at a later date, maybe later today or so. Having said that, now we move to the next speaker. Let me introduce Oren Eza, or Oren Eza, as one may want to pronounce it. He is the co-founder and the CEO of the company Electrion in Israel. Electrion is a publicly listed company in Israel and has reached a valuation already of around $500 million US. So maybe those of us who are interested in buying stock can look at it separately. But he has a very interesting multidisciplinary experience in various international companies. He's also a very good engineer. I realized that when I was interacting with him to get this session organized, and actually has done a lot of work even on the R&D side and project management and so on and so forth. He holds a master's degree in electrical engineering, specializing in signal and video processing. I must mention this additional qualification that he has, that he's an excellent surfer and he's a very adventurous surfer. So I advised him to be a little safe because we need people like him and his company around to push this technology to the next level. Over to you, Oren.
Thank you very much, Mustafa. And I'm honored to be part of this session. So let's start with the presentation. Tel Aviv. Actually, we are focusing on developing dynamic wireless charging system for all types of vehicles. We are holding, we have three ongoing projects, one in Israel, one in Sweden, and one in Germany. And we own 19 patents on the technology. So as we saw already this graph, and we know that the world is fighting air pollution, and we see a major shift toward electrification, mainly in public transportation, buses, and light commercial vehicle, when heavy-duty trucks are lagging behind because there is no good solution. I think that we can divide it into two main problems. One, as we all know, still the battery. It's very expensive, heavy, and with a short lifetime. 500 kilowatt hour battery can cost more than $350,000. So if we multiply it by, let's say, for a fleet of trucks, 1,000 trucks, it will be a very, very heavy capex on the fleet owners. The second problem is, of course, the infrastructure for charging this fleet. Of course, if we have a private electric vehicle, it's not an issue to charge it overnight, but just imagine how much energy and what a huge connection, grid connection we need in order to electrify or to charge 100 heavy-duty trucks on the same time. It could be more than 10 megawatts. So when approaching this problem, we should understand first that we are facing infrastructure problem that must be led by governments. The solution requires funding. So in order to maximize this funding, it is necessary to open the service to a wide range of vehicles. So the more vehicles that use this technology, the more economical it becomes. And of course, it's a huge benefit to have the same technology for highways and for city or urban environment. So electric road system can be a great match for this problem. As we all know, we can electrify the vehicle during the drive, so we don't need to carry a huge and massive battery on board. And of course, while we are charging the vehicle on the move, we can drive 24/7. So this is crucial for fleet owners. They can open the service almost 24/7. So why wireless? We have lots of benefits to have wireless electric road system. First, we can open the service for all types of vehicles, starting from a private vehicle, minibuses, buses, and even long-haul trucks. The second one is there is no visual impact. All components are underground, so before and after the deployment, we have the same picture. And of course, we can adjust the power according to the vehicle needs. We have a generic receiver pad that can deliver up to 30 kilowatt. So let's say, for example, one private vehicle can own or can install one receiver pad. A bus can install 3, and a heavy-duty truck can install 5 or 7 to reach more than 100 kilowatt charging to the battery. And another issue that we can install this technology on all lanes on the highway. So what is wireless dynamic charging? We have 3 main components. The first one is coils that we buried under the asphalt. We open a trench 8 centimeter deep. We put the coils and we cover it back with asphalt. So we can actually repave the road without the need to take out the coils. The second element is receiver pad that we install at the bottom of the vehicle. Actually, we don't need to reinvent the vehicle. We can put it on an existing vehicle without the need to change anything inside the vehicle. And the third component is a management unit that we install at the side of the road. This unit manages a section of a road. So here you can see actually nice pictures from the deployment that we did last week in Tel Aviv. At the left side, you can see the coils during the deployment. And in the middle, you can see the management unit that is under the pavement, and the road in the morning, which is open for the public. Another thing that the technology can provide real-time communication with all the vehicles within the system. So we can provide billing system, and what is very interesting, the fleet owner can manage his fleet remotely. He can reach and can monitor all the vehicles, starting from the battery state of charge, the consumption of every vehicle, and of course the position and location of every vehicle. So it's very, very important. So actually, the main benefit of having wireless electric road system is the fact that it's a shared platform. So we can share this technology between multiple users. So we are targeting two main use cases. The first one, of course, is cities mainly for public transportation, buses. Buses drives in fixed routes, so it's much easier to provide them a solution from day one. And of course, once we deployed it for buses, why not to open it for taxis, delivery trucks, shuttles, and even for private vehicles, without any additional funding, of course. The second use case is, as we all understand, long haul trucks driving on a highway. There is no solution right now, so electric road system can be a great match. And if we will add to this technology autonomous capabilities, we will have the optimal solution, a light truck that can drive 24/7 with a minimum operational cost. So I would share with you now some insights from our three projects. The first one is Tel Aviv, that you can see here. Tel Aviv has an ambitious goal to electrify all public transportation. There are 1,300 buses driving on a daily basis along the city. In order to electrify those buses, the city and the government need to invest more than $500 million. So electric road system, let's say, can shrink this funding more than a half to $250 million. And we can pave the cost estimation for 1 kilometer of electric road is around $600,000. So electrifying all main roads in Tel Aviv, 120 kilometer, will cost, if we will calculate both sides, let's say 200 kilometer, it will cost $120 million. So we save lots of money from day one. So this is the first shuttle that will be the first step before electrifying the whole city. And we are collaborating with Donbus company. It's one of the biggest public bus operator in Israel. Of course, the Transport Ministry, the Innovation Authority in Israel, and the city of Tel Aviv. The second project is in Sweden. As we heard before, Sweden has a huge ambition to electrify all the highways for long-haul trucks. So it's very, very challenging. We deployed last year the first section of road on the beautiful island of Gotland, and we tested the heavy-duty truck, 40-ton truck, on a heavy snow on this road. We plan to pave 1.5 kilometer by the end of this year, and to run two different platforms, an electric bus and electric truck on the same facility. And actually, we are going to install solar panels and to feed the road with renewable energy. So it will be an ultimate solution for reducing pollution. And of course, just to mention that this bus runs on supercup, no battery. We all understand that battery is not so clean and green. So we are using a supercup technology, which is much better than a battery. The third project is a project in Germany together with a company called EnBW. It's one of the biggest electricity company in Germany. In this case, we have a shuttle, electric bus, that will be a shuttle for employees in the city of Karlsruhe in Germany. Actually, in this project, we are going to show that there is no need to pave all the route with electric road system. We are going to pave only at the beginning of the route and the end of the route, and it will be enough to drive this bus all day long. So here you can see some pictures from the deployment that we did, a training session that we did last year in Israel for our partners in Europe. You can see at the right side the first deployment in Sweden that took place last year. Here you can see the installation on the truck, which is very, very easy. The installation took part few days. We don't need to change anything. You can see two wires that goes from the receiver directly to energize the battery. And the weight of the receiver is less than 40 kilograms. A few numbers about the receiver. The cost of one receiver will be around $1,000. So it's a huge benefit if we reduce a huge battery from the vehicle and we add only one receiver or three receivers. It could be a huge benefit and cost effective. One receiver can reach up to 30 kilowatt, and if we install 5 on a heavy duty truck, we can reach up to 150 kilowatt. We can operate with any type of energy source, if it's a battery or if it's a supercap, in a range of 400 volt up to 800 volt battery. And actually we are a current source, which is very easy to install and connect to the energy system of the vehicle. Here you can
Oren,
see
you have about 2.5 minutes left.
good. This is the last slide. So here you can see the deployment on a bus. Very, very simple. We have here 3 receivers at the bottom of the vehicle. When we plan to test 4 or 5 receivers on this bus. So that's it. Thank you very much for the time. And I'll be very happy to answer all the questions. And of course, to have the first wireless electric road system in India very soon.
Thank you so much, Oren, for that, and may your wishes come true. So, as in India, we need systems which can reduce not just petroleum consumption, but also increase renewable energy usage and minimize the batteries. As electrical engineers, we get very excited about power systems, infrastructure, power transfer, and so on and so forth. But we need to understand that while we may get excited about so many things, the consumer of this electricity has to be the vehicle. Now, the vehicle is a very complex piece of engineering, technology, and integration. How will this pan out from a vehicle perspective is something that we have to look at very closely. And there is no better person to address this than my good friend, Mr. Sundaresan, who is here from Ashok Leyland. Also, I must mention that this is one of the first or the first EMA event which is bringing together people from both the electrical industry and the leaders in the Indian automotive industry. So, Sundu, we will be happy to or very curious to hear your vehicle perspective on this whole issue. And I'm sure that there will be a lot of learning and possibilities of co-working and collaboration in this. With this, before I hand over to Sundu, let me just do a brief introduction of him. He is quite an unusual guy. He has been an entrepreneur in the past and a very strong technology innovator. He is an alumni of IIT Madras and he did his post-graduation at Stanford. His past experience is very diverse, both across mechanical and electrical engineering systems, and then subsequently joined Ashok Leyland, and currently he is Vice President, Electric Vehicles and E-Mobility Solutions at Ashok Leyland, and responsible for developing all this stuff about electric vehicles, related solutions and services. One thing I would caution everybody is Sundar is an exceptionally brilliant engineer, and many times he gets insights that all of us get only after studying some books. He gets it instantaneously. With that, over to you, Sundar.
Thanks very much, Mr. I hope I don't prove your words wrong. So
I'm sure you won't.
Okay. Yeah. So both Anupam and Oren have laid an excellent platform for me let me talk more from the vehicle's perspective. They've talked about the different options for getting the power to the vehicle. Now, just a brief background for the electric vehicle. So, if we look at an electric vehicle, as both Anupam and Doran mentioned, it has a huge battery. And you need longer range, you need to increase the capacity of the battery. And then battery supplies power to the motor through an inverter. So the DC from the battery is getting converted to AC, and that drives a motor. And that motor can transfer the mechanical power to the wheels, either through a gearbox or directly. So there are multiple options possible, but the mechanical power gets transferred to the wheels. But the DC power is also required for other auxiliary devices on the vehicle. So typically brake and compressor, power steering pump, and of course it also needs to power the low voltage battery, so that lighting systems, all the other 12 volt or 24 volt systems can draw power. So that happens through a DC-DC converter to power the other electrical systems in the vehicle. And then, as and when necessary, it gets charged from the grid. So this is the architecture of an electric vehicle, and let us see how that. What are the different numbers in terms of power that get consumed by these various aggregates. So a typical vehicle goes through some kind of a drive cycle like this. So this is the drive cycle on a highway in India. So as we can see, predominantly the speed, let me just as we can see, the speed is about 50 kmph, but even on a highway, it is really not smooth. There are braking events, there are acceleration events, and sometimes that can be fairly rapid as well. So this is over a period of 20 minutes, and in that 20 minutes, this vehicle has covered a total of 10 kilometers. So average speed actually comes to only 30 kmph, though from what we see, it is mostly around 50 kmph. So for this kind of a drive cycle, what are the various power flows? Of course, we hope that we get the power from renewable sources, and that comes from through a charger to the battery, and from the battery it goes to drive the vehicle. So that builds up the momentum for the vehicle, kinetic energy for the vehicle. But apart from that, you do need to spend energy to overcome the rolling resistance at the tires and aerodynamic drag. So at 50 kmph, the aerodynamic drag is also fairly significant. So that also needs to be overcome. And if there are gradients in the road, then that to drive the vehicle over the gradient, over an up gradient, you need to spend energy. And of course, the advantage with electric is when it is coming down, we can recover. Apart from that, as already mentioned, all the other aggregates. You have the cooling systems for the battery, for the motors, then the brake air compressor, lighting, all those, they also need energy. And whatever the kinetic energy that the vehicle has built up, during the braking events, we are losing that energy through braking. And then some of it, if the driver is good, while cruising, so if you can identify a slowing down event, then during cruising, that kinetic energy can be used to overcome the rolling resistance as well as the aerodynamic resistance, or even to go up the slope can be used, or you can use the potential energy to convert into electrical energy. So it becomes a two-way transfer of energy. Now with electric vehicle, the biggest advantage is that kinetic energy can also be fed back to the battery, as already mentioned. So you don't need to spend all of it, waste it in terms of this thermal energy lost in the brakes. And even the potential energy that is built up by going up a gradient can be recovered, and it can be stored in the battery. Of course, it comes through this, but just to make it clear, I just put this arrow here itself. So in terms of numbers, what are they? Now, if we look at a kind of drive cycle that I just showed, so starting kinetic energy is zero, final kinetic energy is zero. So ultimately, no energy is there in the vehicle as such. And let us assume there was no gradient, or rather it went up and came down. So the elevation is the same at starting and end points. So in terms of potential energy also, there is nothing, it is zero. But this is for a 49 truck vehicle. So if we look at that 10 kilometer range, a massive 1000 watt hours, or rather 1 kilowatt hour, is lost in the road rolling resistance. And aerodynamic drag is also not much, especially the vehicle is designed appropriately. That is only 50 watt hour per kilometer. But the other aggregates like the battery cooling system, the motor cooling, and all the other losses, they add up to a reasonable chunk of 500 watt hours per kilometer. And finally, because of all those variations, despite the fact that we are regenerating, we still lose about 870 watt hours per kilometer through the brakes. This is partly because at some point if the battery is at an SOC of 90% or something like that, you can't really regenerate because battery is full and the power that it can take kind of gets limited. And especially during sharp braking events, you have to dissipate still that energy. With a mechanical, if we didn't have an electric vehicle, this 870 is actually become something like close to double this, if not more. So with an electric vehicle, we are recovering about 50% of that. But because of other limitations, with an electric vehicle, we still lose about 870 watt hours per kilometer for that kind of a highway application. And if it is a city application, it becomes even more. So this is the kind of energy that we need to provide to the vehicle as it drives on a highway. Now, what are the various factors that have a bearing on these numbers? One of the biggest is the vehicle mass. Again, as it was already mentioned, if we want to go for the long haul, if to increase the range, increasing the battery is the only option, then we in effect are increasing the vehicle mass. Or typically for these cargo vehicles, the GVW is fixed depending on the axle rating. So you are reducing the payload. So for a 49 truck, if the battery itself is about 5 tons or something like that, then the effective payload is coming down by 5 tons. But if the vehicle mass can be reduced by 1 ton, energy efficiency goes up by 4%. So that's the kind of incentive we have for reducing the weight of the batteries or weight of anything that doesn't, that nobody pays for transporting. Apart from this, other issues already mentioned, so cost, the more we increase the batteries, the more expensive it becomes. Another is commercial vehicles, they earn money only while they are running. So if they are parked for charging for long periods, during that time, the hours, whatever for charging, at that time the real estate becomes, that cost also becomes an input. And if you have a fleet, then moving the vehicles in and out for charging, all that, either you need manpower or you need to kind of put in place systems, that also adds to the cost. So ultimately all this, the way a commercial vehicle owner or a OEM look at this multiple issues is one single number, which is total cost of ownership. And that is total cost incurred over the lifetime of the vehicle, adjusted for time value of money, because capex versus opex. Opex is through the lifetime, so we need to adjust for that. That divided by payload and the distance covered. So ultimately, we don't earn revenue for the overall GVW, only for the payload that the vehicle carries. So this is expressed in terms of rupees per kilometer ton. So that becomes an important metric to evaluate any kind of option we want to see for this. And one obvious implication is that the battery weight has to be reduced. And any solution that allows the vehicle to be charged as you go not only reduces battery weight, but also it reduces the time required for charging, real estate, and all the other issues. So with all this, an electric highway is obviously a very natural solution. And as far as the vehicle is concerned, it is fairly easy to implement, as already Electrion kind of showed. All that you need to add is some kind of a receiver. So either from an overhead line or from underground thing, we need to receive that power. So from the receiver, what Warren showed, you get those two. It goes to a distribution box, then to a DC-DC converter to convert this voltage to whatever voltage that is appropriate for the battery. And this battery also feeds other auxiliary converters and feeds the other auxiliary devices. But the main energy goes through the traction inverter to the powertrain to drive the vehicle. So in this, typically this part is already there in an electric vehicle today. So all that we need to add is some kind of a receiver and a distribution box and a DC-DC converter to make the electric vehicle ready to run on the electric highway. This is the case if the electric highway is powered by direct current. And one issue that we need to decide as a country is agree on a voltage for this, so that it kind of gets standardized. The next option that is also being discussed in India is having the power lines as AC and not DC. So in that case, an additional equipment needs to be carried on the vehicle, which is a transformer and then a DC-DC converter, because it makes sense for this AC line to be as carry as high a voltage as possible. So you need to kind of step down that voltage and then convert it to a DC-DC converter through a DC-DC converter and feed the rest of the system. So here this transformer is not only adds weight, but it also adds to the cost. So again, we need to look at the what is the total cost of ownership and take an appropriate decision. Again, as a country, we need to decide on that. So in terms of power considerations, already Oren talked about it. So for the same drive cycle I showed, this is the kind of power that 49 ton truck requires. So as we can see, these are the times at which we are regenerating, and these are the peak power requirements. So it goes up to 500 kilowatts, but average, if we see 100 kilowatts is all that is required. So if this vehicle had 100 kilowatts right from start till end, and with a battery SOC starting at something like 50%, we could have recovered more energy here because battery is still capable of taking in more power, and we would have ended up exactly at the same SOC it would have started at this point. So all in all, we have to kind of design the vehicle and the infrastructure for the maximum power that can be allowed per vehicle. And we also need to take into account potential congestions, or in case of a gradient, if the vehicle has to go up, then the average power also will go up. We have to plan for that so that the infrastructure can power and whatever or the control protocols that need to be thought through, and we need to standardize on that. So to conclude, as far as vehicle technology is concerned, there are no major challenges. Pretty much everything is available. And as I said, the total cost of ownership is the key. And that depends essentially on the cost of power that is made available to the vehicle and the way it is going to be built. And again, as Oren mentioned, this kind of a e-highway can enable additional benefits like platooning or autonomous driving, etc. Because the infrastructure itself can provide additional input to the vehicle, so that lane keeping or those kind of additional features can be added with no or not significant additional cost. And end of the day, this can result in changes to the way goods are transported. So do we need a hybrid truck, or can we just do with a pure electric truck with some limited battery capacity? So if we can identify major segments of the highway and kind of design warehouses within a specified distance from the highway. So whatever battery that the vehicle is carrying may be enough to get the vehicle from the highway to that warehouse, and from there distribution can happen through other means. So once we start working on this, I'm sure the industry will find the viable ways and will adjust. So the way GST impacted in the way goods are transported, this kind of a solution also very quickly result in changes to the way goods are transported, so that overall it becomes efficient and cost effective. So with that, I conclude. Thanks everyone for this opportunity.
Thank you, Mr. Sundaresan. Thank you also for exactly keeping up the time, actually. And particular thanks for you to enlightening all of us about the physics of the problem in terms of energy, in terms of the rolling resistance, in terms of internal consumptions of energy to keep the vehicle operating, whether it is in the form of cooling or auxiliaries and so on and so forth. I think it's very clear that the role of the automobile industry to guide this whole process is very critical. And between EMA and SIAM, which are the two associations that represent the electrical and automotive industry, I'm sure we will find some common ground on how to do this and go on the way forward. At another level, I'm sure the audience has learned a lot more about the dynamics of vehicle movement on the highways. Indian driving conditions are unique. We need to understand that the systems that we design must be compatible with those driving conditions. Though in Western countries or developed countries, the driving cycle may be much smoother. I was surprised to see the driving cycle, what Sundu had shown, where the variations are looking like unpredictable, actually. I mean, it's not really something that can be very easily parameterized. Which means that even the mathematicians among us will have to figure out some good integral calculus to analyze what will be the peak, what will be the maxima, minima, and figure out a way of what is the average. It's not as simple as area under the curve, I mean, anymore. So that's something that we will also have to pay attention to. So specific thanks to Sundar for having raised the physics and the math side of the problem, as well as showing very practically how this can actually, what are the challenges involved, and maybe this has an impact of completely changing the way goods are transported. I think that's a very deep insight. We need to think about that a lot more as we go forward. Thank you for that, Sundu. And now I come to the next panelist. As I mentioned, Mr. Jitesh Khanna was supposed to be with us, but unfortunately, due to his health constraint, he has not been able to join. So in the meanwhile, I therefore introduce Mr. Gaurav Ganguly, who is filling in for him today. He is a senior analyst at McKinsey. He has worked specifically across the automotive domain in McKinsey and focuses on this future of mobility in India. They have a center in McKinsey, which is a kind of a think tank on this issue. So we would like to hear from him. While he's also a good engineer, he's also done his MBA and obviously comes with a comprehensive understanding of both technology, business, and policy issues. So with that, Gaurav, young man, this is an opportunity for you to sort of share your thoughts. And thank you for filling in for Jitesh. And we all wish Jitesh to get well soon. Over to you, Gaurav.
Thank you very much, Mustafa sir. Is everyone able to hear me? Perfect.
Yeah, we can.
And thank you for the kind words. And with that being said, I am in a very enviable position because I am following very respectable speakers, Mr. Sundaresan sir, Mr. Anupam Arora, and also Mr. Odeneza, and yourself, sir. And with that platform being set, let me share my screen. Perfect. So now today we will be talking about the future of heavy duty trucking in India in the, of course, the context is smart e-highways. And I think Mr. Sundaresan has also set the stage very well for me when I start talking about this topic. We will, of course, be looking at the agenda in three different parts, three angles to look at it. One will be, of course, why do we really need to explore the alternative powertrain technologies for heavy commercial vehicles, right? And also then the economic benefits and the strategic partnerships that are required to make this happen. Jumping into the first part of it, right, as we were talking about what is really happening today in India, right? The electrification of the powertrain that we all know about, it is of course one of the go-to methods to reduce pollution and the oil dependency today. So you will see in the slide that we have got electrification in 2030. The rates of the electrification is almost 20 to 50% for two-wheelers, 20 to 40% for LCVs, similarly a bit lower for the passenger vehicles, and all of this is being driven by multiple policy and in demand apparatus, right? We have the FAME policy that is enabler. It's almost a 10,000 crore policy, and that's an incentive for us to do the electrification penetration, as well as the PE investments that are already in the system to the tune of almost 350 to 400 crores that are there. So all of these are acting as enablers to this policy making, as well as the impetus that has been generated for having electrification in India. That being said, which is a nice segue to the targets that we can probably achieve, right, for the expected BEV penetration in 2030. But what is very familiar with us is the numbers on the right hand side, because we see much higher penetration rates expected in those vehicle types. But if you look at the numbers on the left hand side, where we have more of the heavy commercial vehicles, especially the medium and heavy commercial vehicles, if you see on the left hand side, the penetration rates are of course quite less than the others, right? And there are main big things. I think Mr. Sundaresan also mentioned this. The TCO economics are pretty difficult to achieve for a heavy commercial vehicle, especially for a long haul truck. Now, when you come to the TCO economics, how do you kind of look at the TCO economics, right? You break it down into three big parts. You have got the acquisition cost of the vehicle in one place, and then you have got the fuel and the maintenance cost. So you compare with the ICE vehicle, that's basically a combustion engine vehicle, with a BEV or a battery electric vehicle, and you try to see when the parity is achieved. So when is a person is buying that vehicle, will they see the TCO economics kind of match up with each other? So that's the timeline that you want to look at, and that is very much dependent on the high acquisition cost that BEVs today have, specifically for the heavy commercial vehicle. To put some facts to this, right, when you look at some of the heavy commercial vehicle examples that are currently being projected in the market, for example, here Tesla semi-truck. Of course, if you look at the variants that the Tesla semi-truck have been publicized, there is a 300-mile variant and there is a 500-mile variant, in which for the battery capacity of 350 to 500 kilowatt hour, you get a battery weight of around 4.7 tons. Similarly, for the 500-mile variant, you have about an 8-ton battery weight. Now, the battery weight is of course one fact that what it does to you is that it reduces the effective loading capacity for that you can use in that heavy commercial vehicle. That of course once again brings down the TCO and the equity that you have. And of course, once we look at it from the holistic perspective, what are we really doing with a heavy commercial vehicle with a BEV specifically, right? We are increasing the dependency on lithium, kind of substituting oil with lithium or a cobalt, both of elements which are not available in India, and we are to kind of dependent on an international supply chain for that. So that sets the context that of course the penetration rates that are possible for heavy commercial vehicles are kind of less than any other commercial vehicle or passenger vehicles possible today. If that is the case, then what are the things that can resolve this challenge, right? For especially for heavy duty and long haul applications, and we can kind of two parts to this. We have got the heavy duty fuel cells on one part, and the e-highways technology that has been achieved. The fuel cell is of course, it also requires the mature hydrogen infrastructure to make it happen. But e-highways that we are talking about right now, and we have already seen both of the speakers in the first 2 panels talk about the overhead and the wireless charging. So that is of course that can be a tech agnostic way, and as Mr. Sundaresan said, we can of course take the DC power into the vehicle and then make use of it. So if we have this context, right, we should then take a look at this e-highway technologies that we have seen in the Indian context. So that 4 implications that I would like to consider is of course the technology point of view, the safety point of view, cost and the road design point of view. If you look at the technology point of view, there are certain implications that are there here, right? Specifically, when you look at the components for the power infrastructure. So if you see, these will be exposed to the elements, right? Even it's a overhead charging, it will be exposed to the elements. So of course, when you put for in the Indian weather conditions, sufficient protection, of course, will be required for that. And when you look at the pantographs, especially for the retractable pantographs that are to be used in Indian driving conditions, because drivers here tend to overtake and of course do a rapid overtaking and lane changing on the highways, right? So we of course need a catenary sensing actuation system so that the detraction can happen in a proper manner. So those are on the technology point of view. Going from the safety point of view, and this is more of course on how we structure the electricity wires. When we of course look for the AC wires, we are suspending it for 50 or 40 meter high towers, right? But of course DC we have in the road as and also on the overhead. In that case, what we have here is that typical suspension of the wires if it is in a closed duty system. So imagine an Indian Railways context, right? Typically, where we use that is you usually should not encroach into the tracks, and that is something that prevents people from being electrocuted, and of course the loss of life that can probably happen there. But in a highway, is it possible to restrict the access? That's where we have had some limitations in the so far, right? So that's something we should always look at, right? So that we have meet the high criteria for safety. On the cost front, if you look at the creation of the ecosystem for the component structure, so like we have multiple high value components that can be required apart from the vehicle also, right? We have the pantograph, we have got the receivers as Mr. Oren mentioned, etc. Can we make the local sourcing of these components in India so that we can make a cost-effective structure here? And of course, initial insight for the escalations of the cost that can happen in a project, because all of us know that infra projects typically tend to do a bit of cost overruns in India. So of course, escalations, funding, and of course the partnership that are required to get the infrastructure in place are some things we should ponder upon. And of course, the last thing is the road design, because there will be a significant civil engineering and road construction involved here. Because we are not only talking about the highway, but in the electric highway context, we need to have, like say, for the second method that Mr. Oren mentioned, there we has to have a kind of a paved highway. We have to kind of cut off a portion of the road and put in the coils there, or in the overhead structure also. In which case, we should have the infrastructure of the overhead lines along with the highway. So on the civil engineering perspective, we should always, take, inspiration from our Indian Roads Congress as well as the Ministry of the Road Transport, and of course get the design and the peripherals consulted based on that. So that is basically a holistic view on the Indian context, which nicely brings us into the economic benefits, right? Now, so far we have talked about why and how, right? Why do we really need an alternative powertrain and how can we achieve it? And of course, taking a critical look at what are the factors we should look at. Now, that being said, what are the benefits that we can hope to gain and the economic benefits per se for having a e-highway technology in India? Of course, as all of us know that we have a very fertile ecosystem where kind of right now in India for the infra and transportation systems, where the three pillars of change. On one side, we have the Make in India. One side, we have mobility, that is the future of mobility, where we have the connectivity, sustainability, industry localization, and of course the behavioral trends that are coming up. Right, people are more need to be more efficient, need to be more connected, and of course India is not far behind. These what they are basically giving us the impetus is that if we have a catalyst like an e-highway in place, what we can do is that we can unlock a lot of socio-economic benefits as well. I'll come to the economic benefit quantification after this, but on the social, so basically from the ENPV point of view, you basically create, if you see the three buckets that are there, right? You create employment. You of course reduce the time in the logistics, because if you have access control logistics, so traffic jams might go down to some extent. Air quality improvement will of course be there. That's a holistic view on that. If you look at the economy side of things, right, you have the travel value proposition of the freight cost that we can reduce in this, because almost 60% of freight reduces runs on roads today in our country. And if you look at the value proposition here, and if you can reduce the cost of freight by implementing e-highways, then of course that is the one impact we can look for. And of course, what we all have is that if this kind of a technology comes to India, then we will also be in a enviable position to be one of the first movers, right? We have had pilots so far, but if we can take this pilot forward and making it a reality in India, we will see development of knowledge capital and also a localized manufacturing entity, so where we can have the India in a position to be a export hub for such technology in the future. Then what are all of these leading up to? They are leading up to three big things. One is, of course, reducing the dependency on oil imports. We can cut our spend on petroleum as a nation. Then, of course, we are getting the carbon footprint reduced on local as well as the regional scale. And then finally, we can improve the capacity utilization of the power sector, because what I have read about, we can see that we are a bit of over capacity, and that can, of course, when we put a e-highway load, we can have more efficient utilization of the same. So this talked about some of the economic and social economic benefits that can come from having such a system in place, and kind of tying up ways where we can kind of utilize this. Let's come to the numbers, right? Especially, I think some of the numbers Mr. Anupam Arora also quoted, and where we actually see the numbers here. And let us look at medium and heavy commercial vehicles and light commercial vehicles both. Of course, the first part of it is the focus of most here. We'll have about 3.5 million units of medium and heavy duty trucks on the road today. Now, if you look, of course, the numbers are for the total. We are consuming about 500 million barrels of oil annually, and the kind of emissions that we are taking is almost 200 million metric tons of CO2. And if you quantify the impact, right? So if you quantify what is the amount of your cost of, say, importing that particular oil, it's about 400,000 crore rupees in fuel. And imagine if you have a GST emissions of that 200 million metric tons, if you eliminate that by not burning that fuel, then of course you can quantify to almost 50,000 crores of GST emissions. Of course, we are kind of quantifying emissions with the kind of cost of emission and kind of clearing that up from the environment. And these are the numbers that we are looking at, right? So roughly 450 to 500,000 crores of inbuilt savings that we can estimate from having an e-highway in our system. So that's putting numbers to the overall infrastructure situation and the society that we talked about in the last slide. So I think just to then a very nice segue from there is, we have seen so far the numbers that why are how we can kind of take advantage of the benefits of the e-highways after we have talked about why we need the e-highways.
Gaurav, you have 2 minutes left.
Super, thank you so much, sir. I think I'm almost done. The last section is just a single slide. When we have, as we have talked about, that currently why do we need the e-highways, and also what are the benefits of that. Now, how do we really make this happen, right? And of course, we have a separate track for this after this in a panel discussion. But just to make the segue for that, we will basically have to take a look at the ecosystem that is there in the e-highways, right? And if you look at this, there are multiple players, there are multiple complex mix of stakeholders in across industries, right? As Mr. Mustafa was also sharing, that we have the vehicle industry, we have got the infrastructure industry, the road owners, the operators, power grid companies, electricity suppliers, many players from different industries coming together to create a solution. Now, there are, of course, inherently there will be different challenges when you have so many players of different industries coming together, and it is a common forum that will be able to help to bring all of them together and make sure that the discussion moves forward in a very constructive manner. So this diverse group of stakeholders, if they work together in a unified manner, and of course they're ably supported by the government with good policy making, as well as that can be the catalyst for this initiative. So we have a nice platform like, say, today's platform, or going forward, whatever platforms that we can come up with to support this system and make it a success. That being said, I will await your questions at the end of the discussion. Thank you so much.
Yeah, Gaurav, thank you very much for that, and thank you for respecting the time limit. I know this is a difficult topic to confine in 15 minutes, but that was a good summation of this. I think it's very clear as to the socio-economic benefits that electric highways can deliver. While there are a lot of technical challenges and a lot of multi-stakeholder cooperation challenges, I would like to remind everybody that in our country, it's a good example of most of our phone subscribers today have gone from no phone directly to a mobile phone. So in India, we are capable of making these leaps. We are capable of making these climb up a very high mountain, which other people may think is very difficult. We have a combination of very creative Indian minds combined with a very solid concept of Jugaad somewhere in between, coupled with a fair understanding of the engineering and business disciplines that need to be marshaled for this. So thank you for that. I think it's a very clear indication that the socio-economic angle and the benefit of that to the country at large will be very significant in very large numbers, not just in financial terms, but in strategic terms. Having said this, we have now heard about bringing electricity from above, bringing electricity from below. We have heard about some very interesting things about how vehicle dynamics and driving behavior and the physics and engineering of that needs to be also integrated into this approach. We've heard now from McKinsey a very holistic kind of overview of the socio-economic issues as well as some of the key issues that they have flagged, including the safety of some of these things, which of course have to be addressed very deeply. We now come to the most important, I would say, the MyBAP of this whole concept, and that is Government of India. This cannot happen unless the Government of India makes sort of an effort to push these various issues, and also sometimes maybe arm twist all of us to sort of come to the table and do our duty towards making this happen as a national duty in India. The policies obviously in India are difficult to evolve. We are a very diverse country, many different. I joke with some of my European and Western colleagues that we are not a country, we are a continent. And therefore, whether it is the idli sambar from the south or chola bhatura from the north, we have everything in between. And this kind of reflects our diversity, which has to be managed. There is no better person to address this than Mr. Sudhir Garg. He, at heart, is still an engineer, comes with a deep background from the Indian Railways. His qualities have been recognized that he can also be a very good administrator. So he is actually a kaleidoscope of different colors which have come together in one job called the Joint Secretary to the Government of India. So Sudhirji, over to you to sort of put things in perspective and sort of act as a guide to show the way forward. Over to you, Sudhirji.
Namaskar to all my good friends. It's a real immense pleasure for me to talk to this August gathering, and I'm really happy to be joined by very eminent panelists from the industry, all spheres of the industry. And I would like to congratulate the team EMA for bringing a very important topic to the table and take it forward. I'm really happy to be alive and vibrant in this environment where so many things are changing fast, changing for good. Another interesting thing which I'm seeing is that the increased vibrancy in the industry, in all spheres of the industry, after the call by Honorable Prime Minister for Atmanirbhar Bharat. So this is such a changing call that we have now taken up the task for ourselves. Now, this is a topic which we are now talking about is a very sunrise industry. And now let's see why this point has come, why there's a need to change in the mode of mobility in which we have been happily driving for so many years. So very interesting points came up that decarbonization is one point. Reducing carbon footprint is very important for us. From other aspects also, I have been interacting with the transporter associations, and in our country particularly, the logistic cost is very high as compared to the developed countries. So there is also a need to reduce the logistics cost, and is it possible to find a alternate model of transportation which can reduce the cost of logistics? So from that aspect also we need to see. And there's a very interesting point which I learned in the process of having dialogue with transport associations, that the present truckers, the drivers, which are the main driving force behind the trucks, have a very difficult and tough life when they deliver and when they work. So their work life cycle is very tough. So can we bring in some better life for them also? Another thing is that asset utilization. The trucks that we ply in the country are running around 250 to 400 kilometers on an average per day, as compared to around 750 kilometers in the Western world. So can we bring in some other method of mobility which can increase the asset utilization? So these are the various things which we are now encountering, which we need to look into that. And then looking at all this sphere, can we bring in a model which is beneficial to all the stakeholders? My fellow panelists from McKinsey brought in a very important point that we have a multi-stakeholder group here. So how can we bring value for all the stakeholders? How do they find, how everybody in the process finds that there's a benefit for them, and still we are able to do the change process. This dialogue which is happening today takes me to the 1950s, when Indian Railways was thinking to introduce a different model of mobility. They had at that time steam engine as the prime mobility model, and another was a diesel locomotive also doing, which is growing fast in the Indian railway system. In addition, they had in very small pockets like in Mumbai and in Kolkata, some electric local electric mobility as well on the trains. But Indian Railway was thinking that how do we shift from these things alone to the long distance other models. So there were a lot of discussion there, and ultimately they decided to go for electric mobility on Delhi to Kolkata track, which is around 1400 plus kilometers. So that was 1950s, and they had discussed a lot, and they found a lot of value in that. So there were tracks available, and they decided to put electric wire on that. And towards the 2015 or so, after running that system for almost 60 years, there was a discussion in railways that should we now shift to 100% electrification. So I'll just narrate the scenario what was in that time. In 1915, Indian Railways was carrying around 1/3 of its goods on diesel locomotives and 2/3 on electric mobility. And for this 1/3 on the diesel, they were paying 2/3 of the total energy bill. And 1/3 of the electric was, and 2/3 of the electric was carrying 1/3 of the energy bill. So cost comparison wise, electric mobility was almost more than double cost effective than the diesel mobility. So after having long discussion under the present leadership and with the blessing of the previous leadership in the Indian Railways, it decided to shift to 100% electrification of its tracks. And this single decision has led to reduction in the cost of their fuel bill from 25,000 crore to around 16,000 crore. So coming to 25,000 to 16,000 means they reduced their energy cost by around 9,000 crore, which is a very important component. So that brings me back that is the electric mobility will be able to bring similar kind of benefits on the highways as well. Then, will the electric mobility bring in some good life for the drivers? Can they have a model in which a driver moves from point A, drive up to point B, maybe around 300, 400, 500 kilometers, and do a 8-hour shift or 10-hour shift, stays there for some time, overnight or whatever it is, comes back to the home. Today, the drivers of the truck, once they are on the vehicle, they do not know when will they come back. And their families always remain in tension and the health is a big issue. So can we transform the health, can we transform of the life of these drivers on the truck? And that's why the trucking industry is also finding very difficult to find new takers for this job. So this is another thing, and which I think if we have a mobility model which is more streamlined. So let's say that if we put up a electric highway on one lane on a 6-lane or a 4-lane highway. So there's a possibility that at some stage we are able to do a dedicated movement on this highway, on this lane. And then we are able to regulate the vehicles, and accordingly we are able to ensure that vehicles travel almost similar distance every day. So that can give increased asset utilization, that can bring a systematic transfer of one driver to another on the highway, and the drivers can come back, or these vehicle operators can come back to their home, and then they can have a better life cycle as well. So I had been also talking to the transport associations, and they told me that if we typically take a present vehicle, a diesel run vehicle, then 50% cost today is towards the fuel. And taking analogy from the railway experiment and railway model, which is being now very, very successful, we find that there's a possibility to reduce this 50% energy bill to around 30 to 35%, depending upon at what rate you get the electricity. And I believe with the benefits of the open access, which has already been detailed out in the policy issued by Ministry of Power for providing power to the charging stations along the highway for the vehicles charging facility installations for that infrastructure. So with the open access, it is quite possible to get power easily around at ₹5 per unit. And with that, I think the cost of energy and the cost of fuel bill can come down to around 30%. So the total cost of operation can easily come down by 20%. In addition, when we have more running hours and better asset utilization, the cost will further come down. So my thought process is that at least 30 to 40% cost we can bring down by changing mode of mobility. So the driving factors, what are the driving factors that we should look at? Carbon footprint is a very important point, no doubt. But in today's scenario, the most important factor which I see for shifting to a new mode of mobility is the cost of transportation. And to me, it seems very possible that this cost can be brought down easily by 30 to 40%. Now, what are the challenges to really shift from one mode to another mode? One is that there are many stakeholders, we have to bring them on one platform. Then there are many technologies. So the e-mobility is one technology which is visible. Fuel cell, hydrogen, fuel is another technology which is visible. So what are the challenges there? And then there may be some other possibilities as well. So how do how do we glide through this? How do we move ahead with that? So we all agree that there's a need to change in the present mode of transportation. More so for India, which is importing fuel. 80% of its fuel is imported today, and trucking industry uses around 40% of the total fuel. Last year, our fuel import was around 8.8 lakh crore. And if you consider 40% for the trucking, that means around 3.5 lakh crore is going for the trucking industry. So there's a possibility to convert this complete value from import to indigenous and large number of creation of jobs for the people out here, and in turn value for all and everybody. So this is another great motivator for us that we should shift now. Now, I think that what we need to do for it is that we create a strong group, a group which is committed for change of this mobility, a group which has all the stakeholders participating in it. I remember 2-3 meetings that I had conducted in partnership with the transport associations, vehicle manufacturers, including Ashok Leyland, Tata, Mahindra, and of course from the electrical industry. And I found that everybody is on board and is ready to take up this challenge. As very clearly brought out that the technology is not a big issue. The real big issue is to make a decision that is it the right time to make a shift? And if we make a shift, where do we do it? How do we do it? What models we create? So the step is that we create a group, and the second step is that we carry out some studies. So once we are able to prove in those studies that in the present circumstances, this is the best model. Let's say the e-highway is the best model, and we should experiment that, and we can start a pilot project. Maybe in a port connectivity area, JNPT is a good area which is having around 200 to 300 trucks, going up to 500 trucks per day, plying in a small circuit. So there's a circuit of around 25 to 30 kilometers in which these 500 trucks fly around. So we can take up such a circuit for a pilot study, for pilot demonstration, and then once demonstration of technology happens, then the scaling up can take place. So this is what,
3 minutes.
so this is what I think, and with large number of very fine minds that we have in the country, there's a possibility to do it, and we have to also think that from where do we bring in money. So I understand that Ministry of Heavy Industries, which has already is working on FAME 2, which is a 10,000 crore policy intervention for medium capacity vehicles. So probably the funds can be requested from the Ministry of Heavy Industry. That is possible. So if we are able to create a strong group and which can do various studies and create a technological model, and then we can take up a pilot, and then we can move ahead. This is what my thought process is, and this is what I think we should now work for it. So with that, I would like to end my today's talk, and would like to welcome a strong dialogue, a strong continuous dialogue between the industry and the government, so that we can really transform this mobility mode and really create value for large number of stakeholders, for large people in the country, and also able to export in future. Thank you very much for giving me this opportunity. Thanks a lot.
Yeah, thank you, Sudhirji. I think you raised some very important points which, as practicing engineers, we don't tend to sort of deal with upfront. I think the issue of transforming the quality of life of the drivers is a very, very important point which needs consideration. At the same time, I think what you mentioned about the journey of the Indian Railways moving from diesel and other types of fuel to electrification over the last several decades to 100% electrification is a very inspirational story, and you have been part of it and you understand it very well. I can clearly see that we have to adopt a similar approach to the highways. Of course, the variables are more, the stakeholders are a little more diverse, but I think that under able guidance and with the support from your colleagues at the Government of India, I can assure you on behalf of the entire industry, not only the electrical, but the automotive and other stakeholders, that we will work hard to see how to rationalize all these issues and fall in line with what the government would like to see as a transformational agenda for highways to become electrified. This is something that I can assure you is at the uppermost on all our minds. And thank you for that perspective. I think it was a very holistic perspective. It covered topics which were sometimes not completely addressed only while we are discussing technology or engineering. So that's a very important agenda. We will factor those inputs in and further guidance from you on those issues. Thank you so much for your time. Having said that, now we move to the next session. I think everybody's got a sort of flavor of what happened in the first session of this, or the first part of this session. We've had a fairly good exposure on some of the key challenges or achievements done on the technology side. We've got a very interesting perspective which makes us all sit back and think and maybe go back to the drawing board and revisit some of our engineering subjects, thanks to Mr. Sundareshan's highlighting of the vehicle part of it and the driving conditions part of it. And the McKinsey team Gaurav has given a very important presentation on how the socio-economic transformation and job creation can be another important imperative in this whole agenda. And I would say to create a kind of an overall sort of perspective on this, a bigger perspective on this, is where Sudhir ji has come in with his story of what happened on the railways over the last few decades. The quality of life of the driver is a very important point. At the same time, reducing petroleum consumption and improving efficiencies. And finally, very important, like Sudhir ji mentioned, is to look at some cost reductions in what you can call as the total cost of ownership, and issues that will satisfy the transporters, who are a very critical part of this, because they will actually be the users of these electrified highways. So having sort of briefly summarized that, we will now open up the panel discussion. The theme of the panel discussion is how do we make this happen in India? And my request to all the panelists is to sort of identify maybe the top three. And there are many things that need to be done. But in today's format of discussion, I think it is more important to prioritize and achieve and identify the top three or top five sort of key issues that need to be flagged and dealt with, and therefore identify a roadmap, sort of a building blocks of a roadmap that can be presented on behalf of the industry to the government for ideation and for maybe refining and appropriate transformation. So with this, we open up the panel discussion. I can already see a lot of questions having come in, but we will deal with them after the panel discussions. So we will again go in the same sequence with Sudhir ji coming in at the end to give a kind of holistic flavor. I deliberately requested him to sort of position himself at the end of what everybody has to say, because his perspective is probably wider than all of us put together. So therefore, we'll go in the same sequence. So with this, I would like to open the panel discussion, starting with Anupam. We will go in 2 rounds. Anupam, you have about 3 minutes to articulate what you feel are the top 3 or top 5 issues that we need to look at in India for making it happen here. Over to you, Anupam.
Thank you, Mustafa ji. So, we have seen that e-highway or any other platform is the technology to go for, whether we want to decarbonize or we want to also bring savings. Am I audible?
Yes, you are.
Okay. So, with the e-highway, we have an advantage that the project can be also implemented in a faster time, because the technology is available from the lateral technology already implemented in Indian Railways. It is important really formulate the policy issues around this. And while formulating the policy issues, what are the specific items to be looked into? One is the business case specifics, as Mr. Sudhir Garg also said that there are different stakeholders. We have utility, we have infrastructure providers like Siemens, we have vehicle operators like Ashok Leyland, and we also have in between the operators who will really operate this. So the business case has to be positive for everybody. Otherwise, this has got no meaning. And I'm sure with the kind of statistics we have, it has to be a positive case. And along the policy issues, then the taxation approach, the operation strategies, the infrastructure installation approach, vehicle technology issues, the public attitude issues, the emission impacts, and compatibility with the international trade, everything has to be looked into. So it's important that without wasting much of a time, the government comes up with announcement of a pilot project, the way the other countries have done. And I'm sure there is no dearth of financial models. The multilateral financing or the PPP, there are enough models available in India and the experience we have in many industries. So there is no issue regarding the financial models, provided the first pilot project is announced. And moment this is announced and the trial takes up with a mass scale implementation, the localization of technology will also create new business opportunities, jobs, and also vital part of the economic growth. That's what I have to add. Thank you very much.
Mustafa, you're on mute.
Anupam, can you hear me?
Yes, I can hear you.
Yeah, from what I understand, you're saying that the top 3 points should be to establish a prima facie business case, identify a pilot and announce it, and go forward with implementation with a view on also localization.
Yeah, moment you announce a pilot and get to learn from the pilot, the policy issues and the various aspects of the policy issues will also emerge out of. So first part is to really announce a pilot project. That's really a must.
Right. Thank you, Anupam. We'll come back to you. I would now move to Oren to share his perspective on what he thinks. He already articulated that he would like to see it in India. So how do you think, Oren, what are the issues involved in making it happen?
So first, I think that it's evolution is better than revolution. So I agree that we should start with a pilot. When bringing new technology to the market, we bring also lots of uncertainties. As described very well before, total cost of ownership is crucial, and the impact on the vehicle, and of course the impact on the grid. Lots of issues to solve. And I think what is more important is to show everyone, all the stakeholders, what is electric road system. Because if we look at the presentation, it's nice, but it will be a different story when you see it in real life, in your own eyes, in India. So I agree that we need to reach as fast as possible a pilot project in India, to start with, I don't know, one truck that we drive on a certain route. We don't need to pave all the route. We can have a small section that will electrify this truck and understand slowly, step by step, to understand the impact of this technology.
Yeah, thank you, Oren, for that. If my understanding is correct, you believe that a small pilot should be done as soon as possible. You believe that while there will be new technology, a lot of uncertainties, and total cost of ownership is something that needs to be worked out over a period of time. While we can start with some assumptions, these uncertainties may change the numbers. But you believe that having a physical pilot for a short distance will actually completely alter the perceptions, apart from generating new ideas and new possibilities.
Yes, correct. And if we can add different types of vehicles like heavy duty trucks, long haulage, delivery, buses, minibuses, because I believe that the owner of the fleet needs some flexibility. So I think that we should give him this flexibility, not to be rely only on one type of vehicle, but to help him with a delivery truck and even lighter vehicles. But I think that in the future, when we will have autonomous, I think that we will be able to shrink the vehicle and split it. And then I think it's important to show not only long haul truck, but more vehicles.
Yeah, fine. I think that's a very valid point because India is a very diverse country and we have a multiple variety of vehicles operating also on the highways. It's not necessarily like you see in Germany or in America where you have only these monster trucks most of the time. But in India, and a company like Ashok Leyland, I know, for example, has multiple offerings to suit these different market segments. Many of them operate on the highway. Thank you for that. We'll come back to you. And now I'd like to move to Mr. Sundaresan. Sundar, can you articulate what you feel are the important points for making it happen in India?
Sure. So I agree that pilots are necessary for us to understand in detail what each technology is about. And I would argue that more than one pilot, we probably need at least 2 or 3 small pilots to start with, just so we understand the different technologies. Should it be overhead versus should it be underground? So maybe instead of calling it a pilot, maybe we call it a technology demonstrator or something. So only after that we will be able to come up with a decent business case. And next phase can be like what Sudhirji mentioned, kind of JNPT kind of a scale model. So that is the next stage, and then we probably take the final decision and roll out. So maybe we need 2-stage evaluation process. So in the first stage, we evaluate the technologies in more detail. Otherwise, it's going to be more a paper-based evaluation, and maybe that would be sufficient.
Yeah, thank you, Sundar. As expected, I would say deep insights. What you are suggesting, if I'm understanding correctly, is a 2-stage approach. One is to actually carry out mini pilots, but in multiple types of technologies and in different locations to better understand the different technologies and the kind of total cost of ownership that may arise from such cases. Having got that experience, you feel that would be the right time to sort of build a business case, not just based on theory, but also on practical data that is collected from these mini pilots, and then move to actually doing what Sudhirji said, maybe like a JNPT, where there is a fixed sort of routing and the trucks are operating, let us say, in a 25 or 30 kilometer loop from on a regular basis, 24/7 or whatever it is. Is that a correct understanding, Sundar, of what you mentioned?
Correct.
Yeah, thanks, Sundar, for that. We will now move to Gaurav to give us the McKinsey perspective on what they think are the important factors to making it happen in India. Over to you, Gaurav.
Thank you so much, Mr. Sivaji. And as the esteemed panelists have already mentioned, right, we have looked at the techno-commercial feasibility that has so far been talked about, right, having a pilot or also kind of scaling it up in a progressing manner. That being said, when we are doing all of this to understand the trials, there are 3 things that we should do in the parallelly. So to enable this ecosystem to be created and to survive, right? So the first thing is, of course, on the manufacturing point of view, on a localization scale. Like we have seen multiple technologies that are involved in this. Say from the perspective that Mr. Anupam Arora also said, that we have say a pantograph, and then
I think we have a internet connection problem with Gaurav.
Can you hear me now?
We can hear you, Gaurav.
Perfect.
Yeah,
I think
you're back, Gaurav.
Thank you. As I said that when we are talking about the techno-commercial feasibility, we should also look about how to enable the system. And the 3 things that we can use to have the system enabled, one is the manufacturing ecosystem, right? So we should put early thoughts into setting up the localization. So we have the components like say a pantograph or a component like a catenary sensing actuator or a component where like the receiver that Mr. Oren mentioned, right? How we can kind of localize these manufacturing in India and create an ecosystem for that. That is one point of looking at things. The other is of course the infra point of view. When we have the addressing the mechanism for addressing anything like a cost overrun or maybe a financing point of view on the overrun to make it kind of easier to have this system in place. So we should put early thoughts into that, having a mechanism for addressal. And then the final thing is of course the a platform or a portal, right, for the stakeholders to come together in one level. So imagine like a national logistics portal we already have planned. Similarly, a portal where all of these stakeholders from disparate industries can come together. Something similar to what we are doing today that can materialize from today is that we can also have parallelly starting.
Yeah, Gaurav, is that it?
Yeah, those are the three things that I feel we
Yeah,
should.
thank you for that. So if I'm understanding you correctly, in addition to the points raised by the other panelists, you are suggesting that we should put in some early thoughts on localization and on the infrastructure point of view. And you also believe that it's important to create this platform as soon as possible on which the diverse stakeholders can come together and get the views aligned so that we do not waste any time in sort of getting cross-connected and creating a noise kind of an effect, to give an engineering kind of terminology on it. Is that right?
Exactly. And apart from not wasting time, the more important focus will be the learning effect, right? Because as we say, the electrical industry and the vehicle industry, both the different perspectives that can come in to make this operational is the key learning we can take from all the industries.
Sure. Yeah. Idea being that 1 + 1 + 1 + 1 need not be 4, it can be 1111.
Yeah.
So that's the kind of thought that Gaurav has. Having heard all this, I would say very interesting and very, I would say, filtered views to focus on what can be the immediate important priorities. I now come to Sudhirji for his perspective on this. Apart from, please feel free, sir, to modify or adapt whatever you heard, because you are in government and you are seeing things from a different height. Whereas we are looking at it from maybe a little lesser angle of perspective, so to speak. Over to you, Sudhirji.
Thank you, Mustafa ji. I think very good points have come up. And the first step, I think, is a dialogue, which I believe is already started now. I still remember a story during my master's days in US. So the professor asked me that, what do you want to do when you go back? So I talked about some big points. Then he said, how many people are with you? So I said, he said, then okay, forget. These big points will remain in your mind only. So the important thing is that we need a small, strong group. A group which is focused, understand the issues, and that has to have established the need, a need which is pressing. Any outsider which listens to the point of view of the group is really able to appreciate, yes, there's a need. And in that group has to have environmentalists as well, technocrats as well, obviously the transporters and truck manufacturers, everybody. And the important thing that we need to keep in mind is that the Indian highways are different than the Western world's highway. So we need to create solutions for ourselves. So then once we have a formation of group, so that group has to discuss on various options and then come out with few viable options, not only one, but few viable options. And then we carry out those few pilot studies. And then once we carry out those pilot studies, then we are able to demonstrate that. And then that's how we are able to move forward. And even in the e-mobility, within the e-mobility also has came out that they can be pure electric vehicle, they can be electric hybrid, electric diesel hybrid. And again, in both the models, there can be various combinations of power and things like that. So with that, I think if we start now, if we start working on creating a strong group, which can take forward this concept and talk to various levels in the government, various stakeholders in the government and try to bring them on one platform, then possibly we can move faster on that.
Thank you so much, Sudhir ji. While you, if I correct me if I'm wrong, but what you're saying, I mean, that example what you gave about your professor asking you the question in America and you taking time to even reflect and answer, I think is very important. I think we have a lot of thoughts. We have a lot of big ideas in our minds, but we need to sort of answer that particular issue that you raised. And while the platform idea from Gaurav is very important, I think within that platform, forming a core group which will drive this is very important. And the four key stakeholders for this group have to be the automobile industry, the electrical industry, the transporters guys, as well as the government of India. And of course, various arms. Government, when I say government, it means different arms of government. There is no one single arm, but there are several which have to contribute to this. Like Sudhir ji was saying, there is a heavy industry ministry, there is a Ministry of Power, there is a Ministry of Renewable Energy, and when we talk about, for example, connectivity platform and ability to manage these highways, maybe even the IT Ministry will get involved at some point. So these are issues that we will have to consider. Thank you for that, Sudhir ji. I think that we've had a fair first round of round robin, which was very concise, very precise, and so on. I would like to now request if anybody has observations on any of the other stuff that they have heard. And let's go in the same sequence. Anupam, would you like to add anything to what you already said?
So, yeah, can you hear me now?
Yeah.
So I would just like to conclude from my side by saying, it has been a very informative session where we have heard the views of diverse participants, right from government, represented by Sudhir and from Ashok Leyland, from vehicle operation, also McKinsey, and also infrastructure provider like Siemens. So, as Mr. Garg also pointed out, it's important to start fast. There has to be a pilot project, but we need to take a smaller step perhaps by formulating a focused set of people who are from diverse backgrounds, understand the subject, and will steer the topic forward. I think with that small step, we can really start with the pilot project. That's all from my side.
Yeah, thank you for that, Anupam. Coming to you, Oren, you are sitting in Israel. I'm not sure how much of India you understand and know, but please remember we are a continent, we are not a country. So, having heard all these views, do you have anything more to add on this?
I think that India should lead this topic. You have all the equipment and the knowledge to do it. So it will be very interesting to see how India reduce pollution from transportation. I think it's a must, and we would be very happy to take part of it. So, and actually, I visit a lot of time in India, Pune, Delhi, Mumbai. So I'm quite familiar with the Indian market.
Good, and I hope you remember your familiarity with the Indian traffic.
Yes.
Yeah. So just to clarify to everybody, since I'm talking about electric mobility and all of us are talking about here, I have been using an electric scooter myself for 2 years now, thanks to the company Ather, and I use it all over the city. I go for meetings on it. It creates some difficulty initially, but now I've got used to it, and actually I find that to be a very effective way of traveling within the crowded Indian roads. Pre-COVID, of course, post-COVID, all the experiences of that have kind of come down. Thank you for that, Oren, and it's very inspirational.
I just will share with you that I have also an electric vehicle, and 20% of our employees in the company acquired the electric vehicle. So I think it's a good thing that we are at the front of them, and we are pushing everyone to buy an electric.
Yeah, that was just to clarify that we have the moral right at least to be on this panel. So, having said that, thank you, Oren, for that, and thank you particularly for highlighting that India can be an early mover and an early adopter of this and lead the way. I think that point is very important for all of us in India to internalize, realize and sort of increase our dedication towards making this happen. It can be a game changer from not just the country's point of view, but also from an economic point of view. And it's interesting that you sitting in Israel should be telling us this. I assure you that we will do our best to see that that happens.
I will add another sentence. It's not only India. I think that India can help in the production phase, and not only for India, for all the Europe, United States, all over. So if it will start in India, I think we can use this knowledge and for the deployment all over the world.
Yeah, it's very sort of, I would say, very motivating to hear a person like you sitting in Israel, looking in from the outside, telling us what our true potential can be. I think that we will have to seriously consider this also. It's as important as changing the lives of the drivers. I mean, I think this is a very important point that we need to all look at holistically and deeply. Thank you for that input, Oren, and thank you for being so supportive of India. We look forward to working closely with you and your country. We are already working closely with your country in many areas. And Indo-Israeli cooperation is very much on. And maybe this will be the next area where that cooperation can be extended into. Having said that, and thanking you, Oren, move to Gaurav. Do you have any thoughts? Sorry, Sundar, do you have any thoughts?
Nothing really to add. I agree, time is of essence. And I think we probably, the small group or core group that gets formed, I think it should kind of adhere to a strict deadline. Quite often we waste time trying to find the best solution, but we need to remember that in engineering we know nothing is 100% efficient. So quite often a timely solution is better than the most efficient solution. With that in mind, I can just pick it.
Yeah, well said, Sundar. We have to remind ourselves that we are not scientists who are aiming for perfection, but we are engineers to make it practical. I think that's an important distinction. A lot of people find it difficult to understand what is the difference between a scientist and an engineer, but that I will explain later because I don't think I should be making jokes on this kind of a panel. So, Gaurav, over to you. Any last inputs?
No, I think, can you hear me now?
Yeah.
Perfect. I think as Mr. Sundaresan also said, and I kind of echo the thought of Mr. Oren and yourself and Mr. Anupam, is that we have two big things. That are the two key things that are coming out, right? Having a core working group, and of course failing fast and actually making that happen, right? Making a a pilot that can happen and kind of give us a view on the techno-commercial feasibility. So having those two things targeted in mind, and of course when we have the core working group, we should have set agendas for the core working group with a kind of a timeline set, right? So that we can achieve things from the core working group. I think that will be putting us in a path of success on this planet.
Okay, Gaurav. Thank you for that. I think it reiterates the whole issue of having these mini pilots going as soon as possible and learning from that and then developing the business case and extending it to a larger part of the country. Finally, Sudhir Saab, last few words from you after having heard this. I hope you found this as interesting as we have. I'm sure you have heard a lot of these things before, so maybe partly it was boring for you. I apologize for that if that happened. So over to you to share your last thoughts on this.
So I'll share one experience that we recently experimented in Government of India here. So the COIR board has been working for increasing the life of the roads, and they've been talking at various platforms that by using geotextile, the village road life increases. Everybody used to appreciate that, and after hearing said, okay, thank you very much, good presentation, and then everybody goes home. So then the Honorable Minister Shri Gadkari Sahab suggested that please get it verified, certified from some IIT. And that is where these people went to the IIT Chennai, IIT Madras. And IIT Madras said, yes, it is so. And they certified that by having geotextile underneath in the village road, it improves the life by 70 to 80%, reduces cost by 20 to 30%. So with that certificate, when they went to the Ministry of Rural Development, they immediately issued a letter that all the rural roads in the country, in the southern part of the country, must use at least to start with 5% of geotextile, geotextile. So that is the dynamics which I want to tell you. So it means what brings is that whatever this group talks about, it has to be certified by a acceptable group. So I think that if we can tie up with IITs and these IITs, one of the IIT or maybe more than one IIT, and start a center of excellence with them, or when we start taking it forward from the beginning, we need to tie up with them so that whatever is being said, it is certified by them as well. So I think that is the place where it will be acceptable. Acceptability will be greatly improved. That's what I think. Second suggestion which I have is that now McKinsey is deep into it. I don't know whether they'll be ready to create a small project report for a small route, maybe like the JNPT route we're talking about, like that. And then, as other members also said, we need to take up some 2-3 models to experiment, and the fundings are available even from DST and obviously the Ministry of Heavy Industry. And as I remember, in Germany, the fund has been provided by the Ministry of Environment. So probably in India, Ministry of Environment also will play a key role in that. So with that, these multiple stakeholders coming together and then driving this model with a certification from an accepted organization in the country, I think we'll be able to move forward.
Thank you, Sudhirji. Very, very interesting hints, and I would say very interesting directions that Sudhirji is sharing. Thank you for that. At one level, Gaurav, you have your work cut out now. Sudhirji has challenged McKinsey to prepare a project report. So please discuss with your partners and come up with some sort of thought process on this. We will obviously, from EMA and SIIM side, I think we can also pitch in whatever form and manner required. At another level, I think, Sundu, you have work cut out. Sudhir Sahib has mentioned IIT Madras. You are an alumni. Therefore, I think, and you are based out of Chennai. So therefore, how do we get IIT Madras into looking at this and certifying it? Maybe doing a very, not just a mini, but a micro pilot within the IIT campus. Let's say for 100 meters or whatever it is. That can be also one of the things that is thought of, because funding for that kind of thing is available, like Sudhirji says, from DST and so on. So I think that's a matter which I think we have both people on the panel who can play a very critical role in that. And of course, I will be there to support and do some backup work. And I'm sure EMA and SIIM will nominate various people to also contribute in that direction. So thank you very much, all the panel members, for your sparing your time and sharing your views and being very honest and frank about what can be done to make it happen in India. Specific thanks to Oren, who has joined all the way from Israel and sort of given that extra motivation, saying, please show the way India can lead. I think that's a very important sort of psychological factor that we will keep in mind. We will now open the question and answer session. We are running a little late. These questions I'm sure there will be many questions, all cannot be answered today. So we are curating the questions as we ask them, and Gaurav has taken the responsibility of sort of integrating or curating some of these questions and raising them with the panelists. My request to others who have questions even later is to correspond with EMA with the questions. I can assure you that we will compile the questions, channelize them to the respective panel members, get their replies and forward it back to you. So that is something that we can do. Today may not be the right place or time. We don't have enough time to do that. So with that short thing, thank you very much. And like we say from in my part of the country, dhanyavadagalu to all the panelists. And over to you, Gaurav, to run the short Q&A session.
Thank you so much. I have the first question, and I think this is targeted towards Mr. Arora. It is about the cost per kilometer to create the e-highway, including substation, electric overhead, electric line, etc. What do you say?
Anupam?
Yeah, can you hear me?
Yeah, I can.
Okay, so while there are no ready statistics available, but a very preliminary study which has been done around the figures is talking about around $2 to $2.5 million per kilometer of the route for the infrastructure part. So just to provide a very broad context, while there are no further details available, but this is a very broad overview which is right now there. But a lot of details still has to go into it because there are simulations of the type of the road, the inclination of the road, how much would be the spacing between the substations. So all of these parameters, they still have to go into the detailed calculation, I would say. A very, very broad overview right now, not very conclusive.
Gaurav, can I interject there? I think to sort of be fair to Anupam, we must remember that the numbers that Anupam is talking about have come out of experiences of pilots done in the European context.
Yes, yes, of course.
So we need to factor that in, and there the safety requirements, etc., are very different, and the compliance requirements are also very far more complex.
Exactly. And also, Mustafa ji, the moment we localize a lot of parts and with the cheap labor available from India, it is possible to bring the cost down substantially. These are only the ballpark figures from what we have implemented in 3 corridors in Turkey.
Correct. And also the pilot projects are for shorter lengths of highway. So if the whole thing is being done, let us say on 1,500 kilometers in Sweden, as Anupam was mentioning, I think the real cost will emerge when I would say when the size of the project is really something which is real world relevant, not pilot relevant. So sorry, go back to you, Gaurav.
I think the next question is very much related, and I think Mr. Aroraji and others, please feel to comment on that. It is like, how do we reduce this cost in a way, right? And then I think the speaker the questioner has actually given us some one possible solution. Can we reuse certain railway electrical grids for the electrification of the lines? So can we like maybe make the highway stretches along the railway lines so that we can reuse a lot of the grids and we don't have to create that infrastructure once again from scratch? And are these a possible way to reduce the cost?
So I would like to then answer. First was about the reduction of the cost. Yes, cost can be reduced. And as I said, more and more we localize, it is possible to reduce the cost. Further, whether we talk about AC technology or we talk about DC technology, both types of corridors have been implemented, already available in India. So a lot of localization is already done. A lot of localization is still in progress. So there is a ready-made technology which is available with all the standards and the experiences of Indian Railways, which is readily available. Secondly, using railway assets, yes. Using the substations of Indian Railways along the grounds will actually also reduce the cost quite a lot. So it is possible. All types of synergies with Indian Railways is possible with this kind of a technology.
So I would like to add here, like how does a cost scenario changes when you go from a pilot stage to a mass production stage. So Indian Railways, while doing electrification, was earlier doing 25 kV only. Now they decided to go for 2 into 25 kV system, which is using a different set of transformers and things like that. So they initially used on a small stretch, and now they're going for a large stretch, and the cost has come down to almost half as compared to the pilot on which they started. And they're expecting it to come to further half in a decade or so. So that is how the cost really moves up, moves down. So that is you can't really, when you do a pilot or when you're in the initial stages, these costs are really to be considered as too high, and then we can easily factor them half to 1/4 in due course of time.
Yeah, thanks for that, Sudhir. I think that's a very relevant point, that the telescoping of costs happens as you go further and further and go more towards enlarging the size of implementation. Back to you, Gaurav.
Exactly. And thank you so much for the point on the scale economies. I think the last, or not the last, but I think third last question that we have is on targeted towards Mr. Sundaresan. It is about the trucking point of view. So, what would be the cost for a compatible truck? Like if we want to make that truck a reality here for this system to work with.
So it will all depend on what is the range required, because battery is the biggest element. So if we take out the battery, just the electrification probably adds about 20-25 lakhs to a 49 ton truck. So it makes it double. So as compared to a diesel truck, just an electric truck without battery is about twice that. And on top of that, yeah, for every, let's say, 30 kilometers,
Hello.
adding about 20 lakhs kind of.
Thank you so much, Mr. Sundaresan. I think my next question is for Mr. Oren, and this is on the roads point of view, where you have an electrified road. And what are basically some of the challenges that can come to this system? Especially, I think the reader has highlighted things like effect of road flooding. How will a road flooding affect the energy transfer to the vehicle? And such other practical considerations like snow or rain on the road. How will that affect our, the electrical transfer?
So first, just to let you know that another feature that is very important, that the deployment process. I think that the goal is to deploy as fast as possible, not to influence the traffic. And I think that we showed how we can deploy almost half a kilometer in a day. Actually, weather condition will not influence the energy. So we tested the truck on a heavy snow without any problems. So we don't see any problem with the water, floods, even snow. Nothing will impact the electromagnetic field.
Thank you so much, Mr. Oren. I think we have the one last closing question that encompasses everyone and kind of invite anyone who has a point of view on that to come forward. And the question is, broadly, what are the major challenges that can be this system can face, and how do we kind of solve it? And I think we had highlighted some of the challenges, right, in the PPT that we had, but then invite points of views from everyone else.
Who is the question addressed to, Gaurav?
So I can,
It is not addressed to anyone in particular.
so I can start on this. So the biggest challenge lies in our mind. So whenever there's a disruption,
Very
a
true.
visible disruption, you're not ready to take it up. We all know that disruptions are growth motivators, they are the growth engines. We know it, we don't believe into it, we don't want to venture into it. So if the life is going smooth on one path, we are happy with that, we don't want to change it. So this is the biggest challenge. And the second challenge is that who is going to fund, what will happen if we fail, and who is going to take the blame if we fail it. So this is the biggest second challenge. Who will take the financial hit on that? So with these and other challenges are all technology and things like that, they seems to be surmountable, not a big issue. So this is what I see the big challenge.
Yeah, very pertinent observation, Sudhirji. I think that this whole resistance to change has to be overcome, and a cooperative kind of approach with a clarity on the benefits to India, I think will help in overcoming that. We will obviously need a lot of support from the government of India to make that mindset change. I think as engineers, we are a little more open to it. And those of us on the panel are obviously committed to moving in that direction, but we will have to sort of create a public awareness level or at least awareness level in the concerned circles about this issue. I think that's a very important point about public relations and communications on this issue. Gaurav, I would like you to factor that in as a sort of factor that has to be overcome to change the mindset.
Agreed. And I think just to add on, Mr. Oren's point of view about having that fail fast and fail early on, so that you can make it a success later on the pilot project, etc. Right? That is what can change the mindset very fast as well. To make it really see it happening reality in front of your eyes. I think that's also a big important thing there.
Anyway, so for the remaining questions,
Murthy, I have one request from my side.
Yeah.
I observed that the video could not be played. I have figured out what went wrong. So if you allow me, then 2 minutes I can play the video to finish that part.
All right.
Yeah.
You can do that. Since it did not play earlier, yes.
Oh, yeah. Okay. So I have just figured out what went wrong because it was playing on my screen, but not over there.
We couldn't see it. In fact, we tried to sort of wonder whether it was some setting issue, but we couldn't fix it.
Please confirm to me now if you can. Just a moment. Can you see the screen now?
Yeah, I can see the screen.
Okay. So I will try to play. And can you see the video moving now?
Yeah.
Road freight transport
And the sound
predominantly
also.
depends on combustion engines running on fossil fuel. The resulting carbon dioxide, nitrogen oxide, and particulate matter emissions put at risk human health and the environment in general. Here, the e-highway system provides substantial relief and is also economic. Like a conventional truck, the hybrid vehicle has a combustion engine. But in contrast to conventional trucks, the e-highway vehicles also allow for purely electrical operation. To connect the system, a sensor checks whether the traffic lane is equipped with a contact line. The truck then automatically raises its pantograph, or the driver manually initiates the process. The pantograph actively positions itself to the overhead contact line, which is continuously supplied with electric energy by the substations. When connected, the pantograph transfers this energy directly to the electric motor. Simultaneously, it can charge the battery. Sensors and actuators ensure that the pantograph remains connected and that wear is minimized. During braking, electricity is generated as the flow of energy is reversed. This electricity can charge the battery on the e-highway truck, power other vehicles connected to the system, or be fed back into the network. The pantograph allows for flexible operation of the truck in all traffic situations.
So I think that was a short presentation, a short video. Thank you very much for giving me the opportunity to play it again.
Mustafa sir, we need to close this session within next 2-3 minutes. So a kind request.
I was just saying that the backend team will now pounce on us.
Sir, your
We have to
vote is
conclude
not.
this session. Thank you very much
You're not
to all
audible.
of the panelists, the organizing team, and special thanks to the audience who have been patiently listening to this. I hope you found it as enlightening and informative as we all did. With that, I would like to hand it over back to the compeer. And as we say from my part of the country in Karnataka, Ellarigu Namaskara.
Thank you so very much, Mr. Mustafa Wajid, for moderating the session so very well, for bringing about so many different angles into it and really putting together all the elements. And, I think it also helps when we have a fantastic panel like we did, coming from diverse backgrounds, be it the government sector, the corporate world. We also had the global factor in the perspective coming from that. And so once again, I'd like to take this opportunity by thanking Mr. Mustafa Wajid for truly moderating it so very well. And may I also take this opportunity by thanking all our panelists, Mr. Anupam Arora, Mr. Oren Azar, Mr. Sudhir Garg, Mr. S.A. Sundaresan, and of course, Mr. Gaurav Ganguly, who really did put together all those questions. It's not easy to select a few questions from all the questions that have been pouring in from the audience. And I'd like to thank our audience as well, because if it wasn't for all of you, we wouldn't have had an opportunity to make it so interactive. So please do let the questions continue to come in, because in case we are unable to take it online, we'll definitely reply to them offline, and we'll ask our experts what they think about your various questions, and we've already shared them across. So once again, a discussion where we all completely at least agree on one thing, that smart electric highway is the way to go forward. And with a country as diverse as ours, right here in India, we have a lot to look at, from the driving factors to the various challenges, the different stakeholders to numerous technologies available today. We discussed the challenges that are there in front of us, offered a few solutions, and we really do look forward to all of you and all of us, Wajid Saab, using our e-vehicles, or at least thinking on those lines to create a difference ourselves. So thank you once again for weaving it all together so very well. It was an absolute delight, and I think we couldn't have expected a better way to start our conference than with this panel. So thank you once again to all our panelists and our moderator for your kind presence. And at this point, as I thank our delegates, I'd also like to share with each one of you here that we have over 5,000 people who've registered with us, which means very, very exciting times right here. I'd like to tell you that we have a lot lined up for all of you through the day. We have a keynote address by Shri D.S. Mishra ji, Secretary, Ministry of Housing and Urban Affairs, who will share with us a lot on how we have their support in taking things forward. Our next track will be on EV components and charging solutions, opportunities for manufacturing, services and financing, which will be from 2:30 to 4 p.m. Post which we will be starting with our next session on greening the grid, building a resilient and futuristic transmission grid in India, which will be held from 4:30 to 6 p.m. So a lot of excitement all for you. I'd like to request all of you to please be back, stay tuned, because 2 p.m. our special keynote address begins. So let's look forward to a lot of excitement then. Till then, enjoy and experience our environment, and we look forward to seeing you back here on our virtual platform at 2 p.m. Thank you for staying tuned. Once again, I'd like to inform all our delegates that we have a lot of interesting sessions lined up for you through the day. I'd like to request all of you to please be back in the auditorium for our next session sharp at 1:50 p.m. This is going to be a keynote address by Shri Durga Shankar Mishra ji, Secretary, Ministry of Housing and Urban Affairs. So I'd like to request all of you to please be with us and continue supporting us the way you have been. At 4 p.m., we have yet another special address by His Excellency Upendra Tripathi ji, Director General, International Solar Alliance. So, two dignitaries will be joining us through the day along with our panelists. So, I'd once again like to remind each one of you to please be back in the auditorium at 1:50 p.m. Till then, you're welcome to enjoy lunch and experience our environment out there. Thank you.